So we are starting our course after a brief gap because you had to prepare for your last semester course. So I'll resume. The good part of making these videos is that I need not revise because you can always go back to those videos, right? So till now, what we have done is in this course is that we have defined the control systems, right? And we have studied the block diagram, that how do we represent a control system using block diagram, and how do you represent systems in block diagram using Laplace transform. So till now what we have majorly done is that we have represented our system using a block diagram, and we can call it GS in the S domain, the Laplace domain, right? And connected to this is the controller, let me call it CS, right? And this is the output of the system, right? Let me call it OS, right? And that is taken as a feedback, right? The sensor will have its own transfer function, let me call it HS, right? And we compare it with a reference value. So there is a reference value, and we compare this feedback with this, and this is fed to the controller, and the controller decides the corrective action based on the error between the desired reference and the actual output of the system, right? And this goes. So we have till now tried to model this, right? Physical systems in the form of GS. We have tried to find the transfer function for various physical systems. So you would say that the next logical step would be to find or to design a control system for the problem, right? But that is not usually done in industry also, and we would also not be doing that. Instead, having found GS, we will try to find out the response of GS to various inputs, right? We'll try to find a response, the transient response mainly, due to various standard inputs, right? So that is the next thing that we are going to do in this course, that we are going to find the response to various standard inputs of our system. Okay. So let's say I have a system GS, right? There is no controller, there is no feedback, just a system GS. It is given some input, let me call it IS, and when as an output I get OS, right? So we know GS definition is output upon input. That is how GS has been defined, and that is how we have found it, right? Now, before we try to find the response of the system, there are two things, two parameters of GS that are very important in the analysis. So two parameters of a transfer function that are quite important, and those are, number one is the poles of the transfer function, right? Poles of the transfer function. Now what is poles of the transfer function? Poles of the transfer functions are defined as those values of complex variable S, those values of complex variable S for which the denominator of GS, that is the IS, right? For which the denominator of GS goes to 0, those are called as the poles of the system, right? For which the denominator becomes 0. Those values of S are called as the poles of the system, right? That means those values of S for which the GS would go to infinity, you can say. The next important parameter is zeros of the transfer function. Zeros of the transfer function. And zeros of the transfer function are defined as those values of S, right? Those values of S for which the numerator of GS goes to 0. That is, those values of complex variable S for which the transfer function becomes 0. Those are called as zeros of the transfer function. Right? Thank you. We'll continue in the next video.